Good morning. Today's topic is electrical earthing. In last lecture, we have seen about DC motor. We have seen the operating principle, construction, the EMF equation, numerical problems and that. And also we have seen where we can use DC motors. And in today's class, we will discuss about earthing. We will start with the need of earthing, why we should go with electrical earthing, and what are the different types of earthing, how it is being achieved, and what are the advantages which we do have with electrical earthing. So I'll start with the simple introduction of earthing, why we do require earthing. Earthing is basically defined as the process of transferring the discharge of electrical energy directly to the earth with the help of some low resistance wire. I'll show you. Let us suppose you can see that I'm holding right now my laptop now. Now let us suppose most of the times when you are at homes, when you touch any electrical equipment or any surface of any electrical body, you might be experiencing a little bit shock. Now this is a big question. Why do we experience a shock when we touch any equipment? Normally, the equipments are so designed that no current passes onto the surface. Everything current passing will be internally only, unless if it is a bare conductor. See the transmission lines which are running over us, they can be bare. If we touch them, then we should get a shock. But the basic equipments, the laptop, the mobile, the TV, the fridge, if we touch them, we shouldn't get any electrical shock actually. But sometimes we do get electrical shocks. Even when we touch our walls also, sometimes we will be getting electrical shocks. So what is this? Why it is happening? It is because the electrical energy is being moving on the surface of these bodies. So you should ensure that whatever the electrical energy, whatever the electrical discharge is there on the surface of the body, it must not go to us. It must not pass through us. It must directly go to the ground. Because ground is a very good absorber of everything, right? It is electrically considered as a neutral one. So any charge it can directly take it. So we should ensure that all these equipment, they should be provided a path to the ground, such that even if we touch it, we don't get any electrical shock. So how to achieve that one? You just take a small wire of least resistance, connect that surface to the ground. This process is called as earthing. So that's what I have mentioned here. The process of transferring the immediate discharge of the electrical energy directly to the earth by the help of some low resistance wire is called as electrical earthing. So how it is being done? It is done by connecting the non-current carrying parts of the equipment or neutral of the supply to the ground. Mostly what we do use is nothing but we will be using galvanized iron. I call it as GI in this entire video. GI is used for earthing. It is a very good material, galvanized iron, which generally is used for earthing. Okay. The advantage of earthing is that whatever the leakage currents are there which are flowing onto the surface, that they will be moving through this earthing points or earthing mode. So the short circuit of the equipment, it passes to the earth which has zero potential, thereby protecting the system and the equipment from further damage. Now, how to do the earthing? The simple way, earthing can be done electrically by connecting the respective parts of the installation to some system of electrical conductors or electrodes, place it near the soil or below the ground level. So if I do have the equipment, what I should do, and if this is the grounds, I should connect the surface to the ground. Normally, the earthing mats or the electrode under the ground level, see normally it will be connected to some conductor here below the ground level. So whatever this electrode or the earthing mat which we use, it will be having a flat iron riser through which all the non-current carrying metallic parts of the equipment will be connected. So when a fault occurs, the fault current from the equipment, whatever the current which is fault one, it flows through the earthing system to the earth and thereby protects the equipment from the fault currents. At the time of fault, the earth mat conductors, they raise to the voltage which is equal to the resistance of earth and multiplied by ground faults. So don't remember all these things. Being an electronics engineer, you may not need all these things. But try to remember that this earthing will protect you and the equipment from the fault currents and also from the leakage currents. Okay, so this is a simple picture. What happens when there is no earthing? So this is your normally. This is your live wire. This is your neutral wire. Now these two are generally fed to your equipment. Now let us suppose unwantedly or something, there is some current which is flowing onto this body, which is unwanted. Now if you touch this one, the current will flow through you to the body. Okay, this is what happens. It flows through you to the ground. To avoid this one, what you should do, you should provide some sort of grounding connection or earthing connection. So instead of going through this one, it must directly go from some point to this point by passing you. Right. So this is the easiest way. What I am doing here, see, this is my earthing I have provided. So instead of going through you, through a human body, it is directly passing on to the ground because it is the least resistance part. Ensure that it is a least resistance part. Okay. So this is the advantage of neutral earthing. So now we don't experience any shock. Okay. So normally, what is the current which is flowing through a human body? This is always a big question for most of the people. Our body generally can withstand a current of few milliamperes, not more than that. Anything more than that, we will receive a shock. And if anything is in the magnitude of amperes, then we will receive a huge shock. And if it's still higher, we may get paralyzed. Parts may get paralyzed. And if it is still higher, we may get a heart failure also. So, normally what is the current which flows through the human body when we touch any leakage current? So, the current is generally given by the voltage which is appearing opposite by the resistance of the insulation, the resistance of the body and the resistance of the earth. Generally it will be very, very low. And the resistance of the human body, it will be somewhere around, it will vary between 1000 to 1500 ohms. Resistance of the insulation will be in mega ohms. So every time the insulation resistance, it protects us. But if the insulation fails, then there will be a significant amount of current which will be flowing in the human body, which we call it as a shock. Okay, so if the insulation fails, current starts to flow through us. So to overcome this, what we should do, we should provide in a parallel path, we call it as a ground. Okay, so how to ground the things? There are two types which are generally employed. One is neutral earthing, the other one is equipment earthing. So electrical equipment mainly consists of two non-current carrying parts. One is a neutral, the other one is a ferrite. Both will not carry any current. Both should not carry any current. So you can ground either this one or you can ground this one. Okay. So this is neutral earthing. See, if it is a three-phase system, your current must flow in these paths only. This neutral point should not carry any current. So in a star connected system, you will be having a neutral point. This can be grounded. So if there is any fault, then the current will be flowing through this one. This is called as neutral earthing. So in this point, you will be using a GI wire. See, the neutral of the system generally is star connected system. In delta, you won't be having any neutral. Neutral of the star system is directly connected to earth with the help of GI wire. It is also called as a system earthing. Okay. Normally provided when the system has star winding. Okay, generally for generators, transformers, motors, which are star connected, you will be using neutral earthing. Now the other one is an equipment earthing, which you can see that if any equipment is bolted onto some surface, that bolted point, right? So this one you will be giving a wire and this will be grounded. Okay, see this is your, for this crimp you are giving your ground wire and this is onto the surface. This is your surface of your equipment. So normally your surface of equipment is not supposed to carry any current. But here, what I am doing is I am trying to, if at all if there is any leakage current, then it may flow onto the surface. So immediately what happens? I am giving a connection directly to the ground onto the surface. So whatever, if any current is flowing on this one, immediately it will go to the ground with the help of this GI wire. Okay. So the non-current carrying parts of the equipment like the metallic frame is connected to the earth by means of conducting wire. If any fault occurs in the apparatus, the short circuit current passes to the earth by the help of the wire. Thereby it protects the system and also the user who uses it. So what are the advantages of this one? It is essential because it protects the personnel who is using it from the short circuit currents. And it also provides the easiest path to the flow of short circuit currents, so that the insulation doesn't fail off. Even if the insulation fails, then it provides safety for the personnel and also for the equipment. And it protects the apparatus and personnel from any high voltage surges or lightning discharges. Ultimately, it is about your safety precaution for both the equipment and also for the user who is using it. Now, how it is being achieved? There are two methods: neural earthing or equipment earthing. Then how it is being inserted into the ground? You are getting some wire, right, from either from the neutral or from the equipment, right? So how to ground it basically? So what are the methods of grounding? What are the types of grounding? So to ensure the low resistance part, there are so many types of grounding which are generally practiced: plate earthing, pipe earthing, rod earthing, horizontal strip earthing. But generally the first two are widely preferred. So I'll discuss the first two in this lecture. The first one is a plate earthing. In the plate earthing, what you will be doing is you will be taking a surface. So let us suppose this is your surface. Now I'll be taking a pit of a standard size 60 by 60 by 6.3. Sorry, this is a plate, right? So I'll be taking a pit and I'll be taking a plate of this size. This is a GI plate and I'll be placing its face vertically. And not less than, this length must not be less than 3 meters. To this one, I will be connecting the wire which will be brought out. Okay, and this area will be filled with coke, salt. Coke means charcoal or something else. Okay, and a wire will be drawn through a GI pipe and is perfectly bolted to the plates. Okay, the earth thread must be a GI wire or a GI strip of sufficient cross section area so that it must carry good amount of fault current. Okay, so normally a cast iron or a mild steel frame with a car having a locking arrangement is embedded into the brick masonry to protect the watering arrangement, which consists of a funnel with a mesh. And in this entire pit, you will be pouring in some water and it will be covered in a brick masonry, or you can have some sort of strip arrangement also, which is good. Generally we use some sort of bricks so that it doesn't fall off actually. And you are supposed to pour in some salt water. It will act as a conducting material. Okay, and your earth electrode, whatever you are using, it must not have a resistance of more than 3 ohms. If it is a rocky soil, then you can go up to 8 ohms. But if it's a normal soil, shouldn't be greater than 3 ohms. Okay, so the biggest problem with this one is you should check that there is no discontinuity of the wire. See, this is your plate earthing picture. See, this is your pit which I am taking in. This entire brown color is my pits. See, what I am doing is I am using a cement concrete here. Okay, and this is my bottom one. This is my earth electrode. This is my earth electrode. To this one, if you carefully see, this is bolts are there, and it is filled with coal, salt, or sand. And here I'll be getting a pipe through which it is being done. So this is your earth connector, and this is your pipe. And here I'll be drawing up water. This is actually diagram, but how it actually works, I'll show you a small video. In this video, you can see how it is being done. So you can see that this is the pipe and the salt is being used, and see, this is your plates. This is your plate which I have been talking, and this is your GI pipe. See, the plates is now, it is being inserted into a pit now, and it is fixed there. One minute. So this is the sand which is being poured into this pit, and apart from the sand you will be pouring in coal, the coke what we call it as, the charcoal will be poured into this one, and over that you will be using salts to fill in the things, and the pit will be filled accordingly. Now you will be filling it with some sort of water. Now to this bolt which you do have, now for this one you will be filling in the wire. Okay. So this is the way how you will be filling in, you will be doing your plate earthing. Okay. This is the way how we do the plate earthing. Now the second one is your pipe earthing, where you will be taking a GI pipe and you will be directly vertically inserting it into the ground. And this will directly act as an earth electrode. And the same, how much deep you are supposed to fit in, it depends upon the condition of the soil. And then your earth wire is fastened onto the top section of the pipe through boards. And the pitch area around the pipe is generally filled with salt and coal mixtures, just as you have seen in the previous video. The only difference is that whether you are using a plate and a pipe. In the previous video, actually they have used a plate, but the fitting was done just like a pipe earthing. Normally the wire will be basically, it will be fitted on directly onto the plates. Okay, but the fitting was done just like a pipe earthing, where the earth wire is fastened to the top section. Okay, so I'll show you now how pipe earthing is being done. Both of them, they will be having the same similar type of things. Now see here, this is your pipe electrodes. Okay, where it is being filled with coal, sand and water, etc. And here on the top you will be having your earth leads. Okay, now I'll show you one more video of your pipe earthing. This is made up of copper. So like this earthing will be done for most of the equipment. Okay. So I hope you have now understood how this pipe earthing is being done, and earthing, whether it is pipe earthing or neutral earthing or plate earthing or whatever type which you are choosing, it is just to protect your device so that it can transfer the unwanted charge directly to the grounds. And why we go for that? In order to avoid any fatal shocks for the user and protect the user, and also protect the equipment for getting damaged. Okay. So what type of earthing you choose, it depends upon your choice. But ensure that you do have a good earthing even for your home also. Okay. I hope that now you are able to state the need for electrical earthing and describe the different earthing methods and your homework. You should get a small notes on the need for electrical earthing, how it is being done, and in particular, a neat sketch of how grounding is being done for your home or for your apartment. Get a picture of that and you identify what is the type of grounding and get back to the class. We will discuss more on that. Thank you.